What up? I got my windows open today. It's a really nice day outside. It's like 70 something degrees. Today we're going to talk about tape. We're going to talk about setting a machine up, calibrating it, getting it in the best working order that you can so that it functions properly and you can record to your tape machine. I'm hoping that this video could help you understand a couple key points going into the next video, and by the time you get done watching these two, between all this, you should be able to set your machine up and calibrate it and have a pretty good understanding of what you're doing and why you're doing it that way. So before we go any further, here's my disclaimer. I'm not an engineer. I've not ever been an engineer in a studio. I've never even worked as an apprentice in a studio. I'm a musician. I'm a bass player, and I started recording my own music in 2020 because the band I was playing in for a long time broke up and the rest of the world stopped turning because of COVID. Recording music was something I wanted to learn more about, and that seemed like a really good time to dive into it because there was nothing open and nothing else to do for a long time. So I started on a laptop with an interface, and this kind of spiraled, and now here I am with a fucking tape machine in my living room. A couple things that you're going to need going into this. First off, you're going to need what's called an MRL tape, which I have right here. This is made in a laboratory by scientists. You're going to need to look in your manual for whatever machine you have, and it's going to tell you what operating level, so what fluxivity level, and it's going to tell you what test tones you're going to need to do the calibration on the specific machine. But this particular tape operates at 15 inches per second, or IPS if you want to be fancy. It uses an IEC1 equalization curve, and it operates at 250 nanowebers per meter. So it has a reference fluxivity of 250. This tape has 4 frequencies, and those are 1 kilohertz, 10 kilohertz, 16 kilohertz, and 50 hertz. And you're going to need a set of these, or at least one of these little screwdrivers like this. It has a ceramic tip or maybe a plastic tip, just not metallic. No metal. You're also going to need one of these. I got this off of Amazon. I'll put a link in the description. This is a tone generator. It also has an oscilloscope on it and a multimeter. It has these little B and C connectors on it. One of them is for the tone generator, and the other two are inputs for 2 channels, so you can have 2 things coming into the oscilloscope. This is a Tascam MS-16. It's a 16-track machine. So it has 16 inputs, 16 outputs. The record head has 16 tracks on it. The playback heads have 16 tracks. So if you record something to channel 1, or you plug something into channel 1, it's going to record to track 1, and then it's going to be played back through the output for channel 1. Each channel has a VU meter. So you have 16 meters. And then behind that, each channel has a tape card. You can see it's just a circuit board, and the signal, depending on how you have the output select, is going to travel several different routes via this circuit board. There are little potentiometers and these little white circle thingies here, and they have a little slit in them for a flathead screwdriver, and you can adjust the gain levels via these little potentiometers, and then we're going to use these when we calibrate the machine. It's part of setting it up. We're going to make sure the levels are what they need to be. Let's talk about these tape heads and how this machine works. The tape is going to start over here, and the path is going to go this way. So you're going to have tape running this direction, and it winds up over here on a reel that is not here right now. This is the direction of the tape path. The first of 3 heads we have here is an erase head. Its only job is to erase whatever's on the tape. The next place along the path is this middle head. We'll get to that one in a second. This last one is a reproduction head, a repro head. The only job of this head is to play back whatever has been recorded onto the tape. So this middle head, which is a record head / sync head, has 2 jobs. Its first job is to record whatever signal you're sending to that channel onto whatever track correlates with that channel. And then the second job is it also acts like a playback head. And the reason we have these is so that you can play along with things that have been recorded in real time, and you can hear yourself in real time. Because as the tape travels, if you record here and you play back here, there's a delay, which is where we get tape delay from, which is pretty cool, but we don't always want that when we're tracking and you're trying to record a bass line. You need to be able to hear the drummer play back here and at the same time record your part here. And that's the reason we have a sync head. So each one of these two heads play back whatever's on the tape depending on how you have this output select set. Next thing to talk about is the output select setting. On this machine, that's what it's called. I'm not sure what it's called on other machines, but this one is output select. Depending on how you have this set, that's going to determine what signal goes to the outputs, and it's also going to determine what the VU meter is reading. So the first selection on here is input. Now this is a lot like in Pro Tools. You're going to have something you're going to record, a microphone on a guitar amp or whatever it is. So you set up a track on Pro Tools and you label it guitar, and then you click that little I button on there, and that I is for input. So now you can monitor the signal that's coming in, the input signal. While what's his name's playing guitar, you can make adjustments to make sure you got a good level going in, a good recording level. And the meter on Pro Tools is going to reflect whatever signal is coming in while that I is selected. If you select input on this machine, the same thing is going to happen. Whatever signal you're sending in is going to be monitored on the VU meters, and it's going to go directly to the output of whatever channel you're on. So that way you can monitor it wherever the hell it goes after that. Let's talk about the signal path through the machine. A signal comes in, it's being recorded, and then it's being played back. Throughout this process, there are several places along the signal path to make adjustments in gain. And what we have is gain staging, basically, from start to finish. And this is a lot like if you have a guitar, and the guitar goes into a overdrive pedal, and then it goes from there to the guitar amp. Well, along the way, you have several opportunities to change the gain level, either up or down. So let's just say you have that set up and it sounds really good, and then you want to increase the gain on the pedal, which is the second thing in the chain. So you turn that up. That's going to increase the signal to the amp, which is going to still amplify it the same, and it's going to make it louder. So if you want to keep it the same volume, when you increase that gain on the pedal, you have to decrease the output on your guitar amp to keep it the same volume. So each thing in that chain affects the next signal. And that is really important to understand. In the scenario we just talked about with gain staging, when you're recording something, let's say we're recording a signal, it comes in, it goes to the record head, and then it's played back through the repro head or the sync head, either one. In that scenario, you have a signal coming in and it hits this input potentiometer. So you have an opportunity here to adjust the gain. So we do that during the input level adjustment. Then from there, it goes to the record head. But before it hits the head, there is another gain stage there called recording level, which is here. And then it's played back through either one of those two heads, and each one of those has an output gain level to adjust. So today, the way that I want to set my machine up is so that I have a signal coming in and it doesn't overdrive the input circuit. It then goes to the record head, and I want to increase the record level by 3 dB. But if I don't lower the output, the playback level of both the sync head and the repro head, then it's going to be like that pedal in the guitar chain we talked about. It's going to make it louder when it comes out, and we don't want that. So I'm going to decrease the gain on both the sync head and the repro head. I'm going to decrease those by the same amount, by 3 decibels. So my signal comes in, it gets increased by 3 decibels right before it hits the record head, and then before it is played back, it's decreased by 3 decibels, so that when I send something in, it's played back at the same level it came in. Google defines tape fluxivity as the strength at which a recording head prints a signal onto tape. Back in the 1940s, this company called Ampex, that was like the tape manufacturing giant of the time, developed a standard, 185 nanowebers per meter, which is really fun to say. It's an operating level, it's a recording level. So if you have a tape where something's been recorded at 185 nanowebers per meter, and you play it back on a machine, the machine should be set up to play back a tape at 185 nanowebers per meter. The goal was to be able to record at the highest level possible, as loud as you could, without saturating the tape or compressing it. So that was the old standard. It was a reference point that was 0 VU. As tape manufacturing improved and the quality of the tape improved and they could reach higher levels to get above the noise floor of the tape and still get clarity without driving it into saturation or compressing it, they would use that original standard to reference their level of recording. So +3 over 185, which is the original standard, and then +6, and then +9 even now. And so each one of those levels in dB correlates to a certain fluxivity level. So this machine that I have, from the factory, it's set up to work at 250 nanowebers per meter, and that correlates to a +3 level. So it's 3 dB louder than the original standard of 185. The tape I'm going to use today is SM911, and it is meant to record at +6 over 185. So my machine operates 3 dB louder than the original standard, and this tape needs to be set up to operate 3 dB louder than that. So we can call that +6 over 185 or +3 over 250 to make it even more confusing. So today what we're going to do is we're going to use an MRL tape that operates at 250 nanowebers per meter, and if we were going to set it up without increasing the gain, we would play back the signals on this tape and we would adjust the output level to read 0 VU. And then we would record a test tone and we would adjust the recording level to where it said 0 VU. But like I said earlier, I want to record 3 dB louder than 250. So when we play back this MRL tape, which is set up at a level of 250 nanowebers per meter, instead of adjusting the output level to read 0 VU, I'm going to adjust it to read -3 because it's 3 dB quieter. And that way when I adjust the recording level up by 3 dB, this comes up with it and we're back where we started. It's like turning the gain on the amplifier down by 3 decibels, so you can increase the gain on the overdrive pedal by 3 decibels and you still have the same output level. Ta-da! So before we plug anything in, before we make any adjustments on the tape card, we need to make sure that we do the azimuth first. This has to do with the way that the head is sitting. So if you picture the playback heads, you're looking down the path of the tape like this. Path is going this way. The distance between the tape and the head, the surface of the head, should be the same across the width of the tape. So the tracks on your tape heads start here, 1, 2, 3, 4, etc., all the way down to 16. 16 and 1 are on the edges of the tape. So to prevent any weirdness from happening there, we use track 2 and 15. We play back a tone with this MRL tape. We take the output from channel 2, we run it into the oscilloscope, and then we also take the output from channel 15 and run it into the oscilloscope. And that lets us look at both of those waveforms. They're going to be sine waves, so they look like this. And those two should be in phase. So they should move up and down together like this. According to the manual on this machine, these two sine waves need to be no more than 90 degrees out of phase. Ideally, they would be exactly in phase. The azimuth adjustment makes the head do this. So if your azimuth is off, the signal is going to reach the tape sooner here where it's closer and later here where it's further away. So they're not going to be right. So when you adjust the azimuth in this scenario, the tape head is going to go like this until they're in phase. And that means that the distance from the surface of the tape head to the tape is the same here as it is here. And that's really important because you can't really do anything else until you get that right. There's a potentiometer labeled input level. So this allows you to adjust the level of whatever signal's coming in. And the way we do that, we use a tone generator or signal generator. We can program the exact frequency we want, which in this case for this machine, according to the manual, is 1000 hertz or 1 kilohertz tone at plus 4 dB. That equals 1.23 volts. So we set our tone generator to generate a signal that is 1000 hertz at 1.23 volts. And then through these little BNC connector on the back, we run the output from the signal generator to the input of a channel on the machine. Let's just say channel 1. That signal hits that potentiometer that says input level, and then it goes to the output. Our meter is going to show whatever it is, but at this point, we can't really trust the meter because it hasn't been calibrated yet. So we're going to run another connection from the output of channel 1 back into the input side, and this also has an oscilloscope on it. And that's going to allow us to read the signal coming back in. So we send something we know into channel 1, 1 kilohertz at 1.23 volts. On the oscilloscope coming back in, it should measure 1 kilohertz tone at 1.23 volts. And if those two things don't match, that's okay, because we can adjust it right here on the input level adjustment. So we're going to adjust that until it reads the same thing that we're sending in. That is your input level adjustment. Now, while this is happening, once you get that done, under these conditions, we want the VU meter to read 0. And if it doesn't, there's another little potentiometer on here that's labeled meter. And you're going to adjust this until the meter reads 0. Now, this adjustment doesn't affect the signal level at all. It doesn't affect the gain of anything. It only tells the meter where your 0 point is. And we want the 0 point to be under those conditions when you have 1 kilohertz at plus 4 going into the channel. And we're going to do that for every channel on the machine. So once we have that completed, our input level adjustment is done. And now that the meter's calibrated, we can use it for the rest of our adjustments. The MRL tape that I have plays back at 250 nanowebers per meter. So what we would do normally is play that tape back and then adjust the output gain levels for the sync head and for the repro head until the meter read 0 VU. That would mean we were operating at 250 nanowebers per meter. But we want to record hotter than that. We play this tape back, this MRL tape back, and we decrease the playback level on both of those heads by 3. So our meter will actually read -3 because we're going to do that first. Then when we adjust the recording level, we'll bring that volume back up, and then it'll be right where we started. Can you hear me now? Hey! The bias adjustment. The bias is a really high frequency that is blasted onto the tape along with whatever you're recording. My understanding is that it helps ensure that the particles are more receptive to the signal that's being imparted upon them by the record head. Once we're done with the output level adjustment, we take the MRL tape off and we put a reel of whatever kind of tape we're going to be recording to on the machine. In this case, it's recording the master's SM911. So you can look on RTM website and there is a data sheet with all the information about that specific type of tape. And one of those things that's on that sheet is a bias level drop. The type of tape we're using requires a 3 dB drop. So if you look in the manual for your machine, in this particular one, it gives you the information you need about the type, whatever the frequency is you use to bias the machine, okay? We use our tone generator and we send the signal in. It's like this high frequency, makes your eye kind of do a weird thing. We're going to load up some of this SM911 tape and we're going to record a signal to it. Turn the bias potentiometer all the way to the left. So turn it down all the way. While this signal is being recorded onto the tape, we're going to increase the gain on the bias potentiometer and we're going to watch the VU meter rise to a certain point, and at some point it's going to hit a peak. Once it hits that peak, it's going to start to fall. We're going to keep increasing the gain until that needle falls by 3 dB. And depending on the type of tape you're using, there may be a difference. This particular tape wants to see a 3 dB fall. But check your data sheet on your tape, and you check your manual for your machine, and it'll tell you exactly what frequency to use on your tone generator and at what level to send it. Before we do the recording level, we need to make sure the bias is done right. We're going to be recording a tone to that tape, and we want that to be done at the best level it can be. Again, those particles are more receptive to the signal we're sending when it's biased properly. We're going to send a 1 kilohertz tone at 1.23 volts into whatever channel we're going to adjust, and then we're going to record that onto the tape, and while it's being played back, we're going to adjust the level. We're going to increase that recording level by 3 dB. So our signal comes in and it hits the input level, it goes to the recording level potentiometer, and that increases the gain level, and then it goes to this playback or repro head or sync head, so then the signal comes back down where it was before it goes out. So that's really good stuff to understand the gain staging and the signal path while you're recording, because that makes a lot more sense out of everything we do as far as the setup and calibration. Good luck with everything. Happy recording. If you have any questions, leave them in the comments, and I'll do the best I can to answer those. Hit me up on Instagram. I guess that's all I got.